Imagine a world ruled by giants. For millions of years, creatures like the mighty Tyrannosaurus rex and the horned Triceratops roamed the earth. They were the kings of their time, living under a sun that had shone upon them for generations. But one fateful day, about 66 million years ago, their reign came to a sudden and catastrophic end. This was not due to a slow change in the climate or a gradual decline. Instead, their world was shattered by a visitor from deep space. A colossal asteroid, a massive rock bigger than a mountain, was hurtling through the cosmos on a direct collision course with our planet. This single event would change the course of life on Earth forever. The asteroid that sealed the dinosaurs' fate was truly enormous, estimated to be about 6 to 9 miles wide. To put that into perspective, it was larger than Mount Everest is tall. It traveled at an unimaginable speed, streaking through space at roughly 12 miles per second. This is so fast that it could have crossed the entire United States in just a few minutes. As this cosmic bullet entered Earth's atmosphere, it would have glowed brighter than 1,000 suns, a terrifying harbinger of the destruction to come. It wasn't just its size and speed that made it so deadly, it was also the angle at which it struck, a steep 60-degree plunge that maximized the explosive force of its impact. This giant space rock didn't originate from nearby. Scientists have studied the chemical clues left behind in ancient layers of rock from that time. One very important clue is a rare element called iridium. Iridium is not common on Earth's surface, but it is abundant in asteroids. Researchers found a thin layer of iridium-rich clay all over the world, dating back to precisely 66 million years ago. This global layer of space dust is the smoking gun. Based on its composition, scientists believe the asteroid was a special type called a carbonaceous chondrite, one of the oldest objects in our solar system, likely coming from the asteroid belt far beyond the orbit of Mars. The moment of impact was an explosion of almost unimaginable power, far greater than all the nuclear weapons on Earth combined. The asteroid slammed into a shallow sea, hitting with such force that it instantly vaporized, turning from solid rock into superheated gas and dust. The ground it struck was rich in sulfur, and the impact blasted trillions of tons of rock, dust, and sulfurous gases high into the atmosphere, miles above the clouds. This colossal plume of debris began to spread around the globe, a deadly shroud that would soon block out the sun and plunge the world into a long, dark night, from which many species, including the dinosaurs, would never emerge. For a long time, the exact location of this world-changing impact was a complete mystery. Scientists knew from the global iridium layer that a massive asteroid had struck the planet, but the crater, the giant scar left behind, was nowhere to be found. Where could a hole more than 100 miles wide possibly hide? The answer, it turned out, was right under our noses, buried deep beneath the ground and the sea. In the 1970s, scientists working for Mexico's national oil company, Pemex, were surveying the Yucatan Peninsula, looking for new places to drill for oil. Their magnetic and gravity maps revealed a strange, gigantic circular anomaly, a huge arc hidden beneath layers of younger rock. At first, they didn't realize what they had found. It was just a curious geological feature, a puzzle in their data. It wasn't until years later, in the 1990s, that scientists connected this immense, hidden structure with the theory of the dinosaur-killing asteroid. They realized that the strange circular shape under the Yucatan Peninsula was the missing crater. It was named the Chicxulub crater, after a nearby town. Half of the crater lies beneath the peninsula itself, and the other half is submerged under the waters of the Gulf of Mexico. Over 66 million years, sediment had slowly washed over it, burying the evidence of that terrible day under thousands of feet of rock. The discovery of the Chicxulub crater was a monumental breakthrough. It gave scientists a ground zero to study. One of the most fascinating features of this crater is something called a peak ring. Most craters we see, like those on the moon, just have a simple bowl shape. But in truly massive impacts, the rock in the center can rebound. For a few brief, violent minutes after the asteroid hit, the Earth's crust behaved like a liquid. A central tower of molten rock, taller than the Himalayas, shot up into the sky and then collapsed outward, forming a circular ridge of mountains inside the main crater rim. Chicxulub is the only crater on Earth with a perfectly preserved peak ring. To learn more about this incredible structure, an international team of scientists undertook a daring expedition in 2016. They set up a drilling platform in the Gulf of Mexico, right over the submerged peak ring. For weeks, they drilled deep into the seafloor, pulling up long cores of rock from more than 4,000 feet below. These rock samples were a time capsule from the moments right after the impact. They found granite that should have been miles deep in the crust, but it had been shocked, shattered, and blasted upward to form the peak ring. This expedition confirmed how these giant craters form and gave scientists a direct look at the rocks that witnessed the end of an era. The immediate effects of the Chicxulub impact were apocalyptic. The moment the asteroid hit, it unleashed a blast of energy that created a blinding flash and an intense heat wave that spread across the continent. Any living thing within hundreds of miles would have been incinerated instantly. The impact also triggered mega-earthquakes that shook the entire planet and created colossal tsunamis, some over 1,000 feet high, that raced across the oceans, devastating coastlines thousands of miles away. Rocks and molten glass from the crater were hurled high into the sky, some even reaching space before raining back down all over the globe, heating the atmosphere until it felt like a giant oven. After the initial firestorm, a new horror began. The trillions of tons of dust, soot, and sulfur that had been blasted into the sky started to spread, wrapping the Earth in a thick, dark blanket. This debris blocked the sunlight, plunging the world into a deep, chilling darkness that lasted for years. Without sunlight, plants could no longer perform photosynthesis. They withered and died on a massive scale, from the tiniest plankton in the oceans to the giant forests on land. This caused the entire food chain to collapse. The herbivores that ate plants starved first, and then the carnivores that ate the herbivores, like T-Rex, soon followed. This period of prolonged darkness and cold is known as an impact winter. Global temperatures plummeted, and the world that had once been warm and lush became frigid and barren. Scientists believe this devastating cold spell could have lasted for as long as 15 years. The sulfur that was vaporized from the Yucatan's rocks mixed with water in the atmosphere, creating acid rain that poured down from the sky, poisoning the lakes, rivers, and oceans. It was a global catastrophe on an unbelievable scale. Life on Earth was pushed to the very brink of extinction, with ecosystems collapsing everywhere. However, even in this destroyed world, life found a way. While over 75% of all species vanished, some creatures managed to survive. Smaller animals that could burrow underground like early mammals were shielded from the worst of the initial heat and the following cold. Creatures that didn't need to eat fresh plants, like those that could scavenge or eat insects and rotting vegetation, had a better chance. In the oceans, life in the deep sea, far from the chaos at the surface, was also able to endure. The end of the age of dinosaurs was a terrible event, but it cleared the way for the survivors to inherit the Earth and evolve into the diverse forms of life we see today. Scientists are like detectives, piecing together clues from the distant past to tell the story of what happened 66 million years ago. One of the most amazing discoveries came from a fossil site in North Dakota called Tanis. Although it is thousands of miles from the impact crater in Mexico, this site captured the events of the very first hours after the asteroid hit. Researchers there found a tangled mess of fossilized freshwater fish that died on that day. Lodged in their gills were tiny, glass-like spheres, called spherules. These are droplets of molten rock from the crater that were blasted into the sky and rained down across the continent. These fish fossils held another incredible secret. By examining their bones under a microscope, scientists could see growth lines similar to the rings inside a tree trunk. These lines showed the fish's seasonal growth patterns. The final layer of growth revealed that the fish had died during the spring, in the northern hemisphere. This means scientists have pinpointed the exact season when the asteroid struck. This detail helps us understand why some animals might have survived while others didn't. For instance, animals in the northern hemisphere would have been busy raising their young, making them more vulnerable than those in the southern hemisphere who were preparing for winter. While the asteroid impact was certainly the final blow, some scientists believe that the dinosaurs might have already been in trouble. Fossil evidence from the millions of years leading up to the impact suggests that the diversity of dinosaur species was already declining. The climate was changing, and massive volcanic eruptions in what is now India were filling the air with gases, possibly making the world a harder place to live. So, the asteroid may have been a knockout punch to a group of animals that were already struggling. This is still a topic of active debate among paleontologists today. The story of the Chicxulub impact is not just about the end of the dinosaurs, it's also about a new beginning. The dinosaurs that did survive this event were the ancestors of the animals we see every day: birds. All modern birds are descended from a group of feathered dinosaurs that made it through the extinction. In the empty world left behind, the small mammals that had been hiding in the shadows for millions of years finally had their chance. They diversified rapidly, eventually leading to the evolution of bats, whales, cats, dogs, and even us. Scientists continue to study this event to understand how life responds to and recovers from global catastrophes, giving us vital insights into the fragility and resilience of our own planet.